Okay, today I thought we'd talk about building my Zom-Bot-2, the zombie killing robot, or robot killing zombies, or however you like to look at it. You've already seen the demo video of this. If not, I'll link it in the description down below. The STL files will be linked in the description down below. And I can even link to a video of one that I built back in 2015 that actually looks more like the original Zom-Bot-3 artwork. But to get started with this, I think it would just be helpful if you all knew which positions to, 3D print parts in and stuff like that. So we're just going to go through it. I don't really have any of this thought out. Obviously this will be a long and rambling video. But isn't that the best kind? No? Well, enjoy. As best you can. We're going to start with this base piece. This base piece is what's going to hold the legs in place. It holds the DC motor. It holds the on-off switch. It holds the battery pack. It holds the sound system. So everything is based around this, and it prints. As you can see, this is the bottom. It prints like this. And it prints with no supports required. Now the motor that I used in the one that you already watched in the video is one of the TT type gear motors, one of these yellow type, but it's the 120:1, which is the slower of the gear ratios. This one is the 48:1, which is the faster. And I thought it would be fun just to see what it would look like, or if it would even work with the faster one. So as we do this little build right now, we're going to be working with this faster one. Now, to keep everything as small as I did, because it's so compact for all the things that it does, the walking, the spinning arms, the stationary head, the lit eyes, the talking, all of that crap in such a small package when your motor is already this big to begin with. The motor is going to go in motor down, like so, and it's going to be a tight fit with these pieces here. Sometimes, well, in the case of that one, I actually undid this and cut some of this extra plastic off. This is the retainer that holds the motor in place. You actually don't even need the retainer. You can take that off and just put some E6000 glue on the sides of the motor and slide it in place. But I'm going to leave it. It does fit. I'm going to attach, obviously I attached the motor wires to it already, so I'm not trying to solder anything once it's buried up in there. The motor is going to fit super snug, super tight, especially since I haven't trimmed any of that side stuff we just talked about. You're going to want it to go all the way back into the back of the frame and just keep pushing it down till these mounting holes here start lining up with the mounting holes that are in the 3D printed part. And I'm not 100% sure what's holding me up, other than that I do know everything fits snug. Okay, I can see that the side of the motor is just catching. Sorry I can't do this on everything on screen, but it is just me. Okay. I think the holes are lined up. What I'm going to take now, here in America they're called a number 632 screw, and I think I figured it out in other videos what size that would be and for metric people, but it's not really that important. You don't even have to use screws if you don't want to. Trying to get the last one out of the bag here. I'm going to get the old micrometer out. Let's find out for the people that live in the land of metric. So that measures about 3.32 outside, and you want it to be able to self-tap into the motor. So whatever that would be in the land of metric, I don't know. But as I was saying, you don't even have to have screws. There's no reason you couldn't just pump, say, hot melt glue into that hole so it would go into the motor and then form a little head out here. It's just something to keep that motor in place. And actually, as snugly as that motor fits when it's in place, it almost doesn't even need anything. I mean, it took quite a bit to slide it on in there. And again, the camera angle isn't going to be optimized because it's to my left and I'm right-handed. But you can see I put 2 screws in. I'm going to do this exact same thing on this side over here. Just like so. Whatever screws or method you use to hold the motor in, you want to try to keep it as flush as possible because you don't want the screw heads becoming a problem with the leg mechanism. So, that motor isn't going anywhere. This is the front. Imagine a speaker goes there. And so I'm going to take these wires right now while I can still clearly see them. And you can tuck them right up through and just bring them out this front opening. Like so. Kind of get them out of the way. And get them to where we can get to them later. Like so. Alright. The reason I'm working with this piece first is we're going to be gluing the battery pack on here. And I want that to at least have some time to be gluing while we're working on other parts. So let's continue on with this. Before we can glue the battery pack on, you're going to need to put in your switch, if you have a switch. And again, with all my projects, I try to use the same switch, so I'm not always sourcing out new things. In this case, you can see it's just a slide switch. It's about 19 millimeters from hole to hole, 19.2 or something. And typically, it would actually have 6 connectors on the bottom here. It's actually a double pull, double throw slide switch. And I cut all the bottom ones off and one off the top, because all I need is an on-off, and there's going to be a metal axle that goes in the bottom of this base piece that we're putting together in the end, and it would bridge those. So we want to make sure that the 2 that we're going to actually use for switching stuff are on the top. And since I didn't mark the plastic on or off, it doesn't matter which side you put those in. So now I'm just going to tuck them down through the slots I left openings. Get them through there. As you can see, the switch is then just going to sit in like that. And we're going to hold that in place with some number 2 machine screws, which some of the people that sell the switches, I hope they're in this bag. Some of the people that sell the switches provide them with the screws, and some of them don't. Oh, I think I see one of them. Maybe I can get it out with the magnetic end of a screwdriver. There's a lot of stuff in this bag, and I don't want to just dump it all out quite yet, because we'd lose it all for sure then, right? Well, at least I would. Now, wouldn't you know it, the screw is actually not magnetic. It actually is a stainless steel screw. A lot of times when you buy screws and hardware off eBay and places like that, and they say they're stainless, yet they're oddly magnetic, so I don't know. I found one of them so far, so we'll get the one screw in there. Oh, there's the other one. I see it down in the bottom of the bag. Just try to fish it around to where I can get my finger in there. Can almost get it. See, this is where video editing would come into play. Like I say, everything I do is for free. I don't charge anybody. I'm just sharing information. So it's kind of hard to justify spending all the hours that video editing takes, or having a second person run a camera. That all costs money. It's all time. I do want to share with the world for free what I can, but I can't give away my entire life for free. So now we have our 2 screws holding the switch in. In our case, moving it over this way is going to be on, and that'll be off. Then let's take those 2 wires that we tucked through the bottom and run them through to the front, just like we did with the motor wires, so we can get to them later. Just like that. So now everything is passing through and coming up to this opening in the front. Alright, now we can get to the whole part that I was trying to get to, so we can move on to actual builds of others, and that's the battery pack. Just a AA battery pack. And do I care which side I run the wires down? I guess I don't. Looks like they'll go either way. Basically, I'm trying to feed the wires down through, just like we just did with the switch wires. There we go. And I'm going to put some glue on the back side of that. What I really should have had laying out somewhere was a rubber band or something. A person probably could hold that in with hot melt glue. Had I been thinking, I might have plugged in the hot melt glue gun and tried that. But normally I just use like the E6000. It's very rubbery and sticks to just about everything. It's good for bonding dissimilar materials, which in this case, this is definitely one of those. And kind of get the goo on both pieces and let it air dry for just a second. Let's see if I have a rubber band or something sitting down in this junk drawer. Oh yeah, good. So let's go ahead and put that on there. It's going to sit just like that, all the way down, push down right on top of the switch, as you can see, and right in line with the sides. And I'm just going to put a rubber band on that. I know it won't actually be dry when we're ready to move forward later, but hopefully it'll stay in place long enough for us to do what we need to do. Alright, let's set that aside. Okay, what we need to build up next is going to be a leg unit like this. And basically we have 2 outside parts and 2 inside parts. We have the rubber wheels. Only the front is a ratchet. Originally I was going to ratchet both because I like my toys. They usually walk better if you can do that. But the original design I had for the rear ratchet didn't work, and I didn't feel like redesigning it. Then you have the leg itself and then the leg linkage piece. So we need to make one of those. So let's talk about those parts. There's part of one of the feet parts. What shows up good there? Here's a couple of those side pieces. And the other foot part. Here are 2 of the wheels. And the leg, which I'd already painted blue. I think that's all we need from that right now. The linkage. It takes about a day and a half to print all these parts, so it's not too bad. Being that the parts were all small, is why it is such a fast print build time, because the robot itself is small. What I'm pulling out of the bag right now are some metal pins, and there's going to be 5 of them required to do the foot assembly. 5 for each foot. And in my case, I was using some 1/8 inch welding rod. And we'll go ahead and measure that here in a second and see what that is in the land of metric. So it's 3mm. So you need some 3mm shaft. If you don't have some 1/8 inch welding rod, or your local hobby store doesn't have 1/8 inch brass rod, they will. You can buy it online too. you could probably use, maybe if you had an old metal coat hanger, or if you had a large nail or finishing nail, and then cut them to length. In this case, the length is going to be roughly, it's about 23 millimeters, which is good for the people that live in the land of metric. For the rest of us, we're going to be cutting it just under an inch. Let's call it 7/8 of an inch. And the point of these rods, well, let's talk about these 3D printed parts first. We don't want to get too far astray. All of the foot parts print as one file, as I have them up on Thingiverse. So basically you can see this is one shell. Obviously these large holes are where the rods are going to go. So you have a right and a left of this shell. We're going to glue these two halves of the shell together. You actually want to use a glue that melts. This is PLA. These parts print flat, no supports required. You're going to want to use a glue that isn't just a surface bond glue. In other words, super glue is pretty bad because it changes from a liquid into a solid, and unfortunately it's a non-flexible solid. It's glass hard, meaning that if you bend it, it cracks, it never gives at all. And the only reason that surface glues work is they bite into the little imperfections of the surface of what you're trying to glue from one to the other. So if you have a glue that's rock glass hard, fragile if you will, as the plastic parts change in temperature, like if you were to go from inside to outside and the temperature changes, they expand and contract. Well, every time they expand and contract, your glass hard type glues fracture a little bit, and eventually they'll fracture enough where your things will fall apart. I have Christmas resin ornaments, robot ones and spaceship ones out in the hut, professionally made, that have fallen apart because they were held together with CA glues, because they're so hard that as the resins expand and contract, eventually over time, usually about a year and a half, it'll fracture the glue and then your pieces just fall apart. So I always say, if you're gluing plastic things together, you want to chemically bond them. You actually want to melt the two plastics together. And as far as I know, there's really only two choices for doing that with PLA. There's a company that makes that 3D gloop, and it melts the two together. But then there's also, let me get you a tube that's not so dinged up so you can see what we're talking about here. There's also this good stuff. This stuff is dirt cheap compared to the gloop. And the gloop, when you get a little teeny tube, this is probably 15, 20 bucks by the time it's shipped to your house. This entire huge tube was less than 20 bucks shipped to my house. Lasts forever. Good stuff. And it will actually melt the parts together. They're not going to come apart. In fact, if you needed to break them apart, you're going to break the print somewhere else. So let me just see, it's been a while since I used this one. Make sure the end is clear. There we go. Paper clips are good for something. And let's just put a little bit of this around the edge here. You can actually transfer this stuff into small bottles that you can buy at hobby stores that have a needle nose on them, which makes it really good for applying. But if you don't use it all the time, it'll harden up in the little needle nose, and then what do you got, right? Okay, I'm sticking the two halves together, and I'm actually going to take one of these pins and push it from one piece into the other so that I know it's lining up right. See, I'm using that as an alignment pin. And you could put two of them in if you want to. It doesn't really matter. Just like so. Because then you know there's no way it's gluing together not straight. This stuff is really fast. We can continue working just as is. Let's prep the wheels. Let's talk about them. The little ratchet wheels. They print vertically, just like I'm holding them right now. No supports. And if your machine does a lot of elephant's foot printing, you're going to want to clean that off on the holes, because these have to spin freely on the shaft. If they bind up at all, you're going to have a problem. Now on the outside grooves here, I'm going to put little rubber O-rings. And what can I tell you about those? You know, I buy the O-ring kits online, and you just have a whole bunch of all sizes. Basically, the inside groove of this says it's about 9.8. So you're gonna, if you buy an O-ring and they tell you what the inside diameter is, you're gonna want to be smaller than that. Say maybe 9 mm, because you're gonna want it to snap on and stay on firm. You want it. It's like it's the tire. You don't want the tire slipping. But in my little O-ring kits, I just find some that that fit tight and call it good. I'm trying to dig all 4 of those out. Like so. Now, one thing to note is not all O-rings are the same thickness. Sometimes they're very thick. If you had to use really thick ones, then you might find that they rub against the bottom of the foot here or here. In which case you're going to have to take, you know, an X-Acto blade or something and cut a little bit of the plastic away, because these have to be able to move freely. You don't want any binding. And there's going to be a ratchet arm that we put on this front one so that the foot can move forward, but locks. Can't move back. The wheel's not turning now. Now the wheel is turning. Maybe you can hear it. So we're going to be making that. But first, we just take our little rubber O-rings, snap them on to the wheels, just like so. There we go. And I guess I didn't dig the ratchet piece that we just talked about out of the bag. It's got to be in one of these bags. If those are all red, it's going to be a red part. So like I say, the foot part's all printed as one file. Here we go. Here's the ratchet piece. And you can see it actually has a bit of an angle to it. So this is the direction, when it prints, by the way, it prints flat like this. You have to have a little bit of support on this part there. Actually, I just said that wrong. I changed the file so you didn't have to. This one is actually printed like this, if I remember right. Yes, you can tell by the layer lines on it. This part was on the bed. This part was on top. So again, prints without anything. At any rate, this is going to go in. You want it to be able to dig into the wheel ratchet. And this one's it's a little bit fidgety getting it in place. It's not horrible. Taking my 2 pins out. I'm going to go ahead and start a pin. So you can see this is the foot. The wheel pin's going to go here. And the ratchet pin that we're going to work with is this next hole right here. So I'm going to start that. You can see how it goes all the way in. Well, we don't want it to go all the way in yet, because we want to put this piece in there and poke the rod through it. And I'm going to set, again by myself, I don't think I can hold the camera or the part in such a way that I can make it visible on camera. I just don't see how that's going to happen. What I'm trying to do now is to get the pin to go through the ratchet arm, which we've done. The one thing that I didn't do first was to make sure that the little ratchet arm moved freely on the metal pin. I should have done that out in the open, because again, could be a booger from your printing or something, but that little ratchet arm has to be able to move completely freely. And this one is not too bad. It's not dropping of its own weight, even though I have it in place. I'm going to take it out, because things aren't going to work if that doesn't move freely. And somewhere in here, here we go. Got this little X-Acto. I'm going to make sure that these ends are clean. Yeah, now it seems very free. So you got to make sure that that's free on that axle, because if it can't move, things aren't going to work. Your robot legs will move, but your robot won't move forward. And what good is that, right? I mean, the zombies would have to actually walk up and put their heads into the blade then. You couldn't chase them down. Okay. Okay, I can hear it clicking, so it moves freely. So the reason we cut those shafts of that length is we don't want them sticking out either side. When the pins are pushed in, we want to make sure that they're flush or inside a little bit. Okay, the next important thing is going to be the wheel. And as you can see on the camera, if it focuses in, there's a sloped side and a straight ratchet side. We need that straight ratchet side to hit on that pin to lock, but when the wheel rolls forward, we need the slope side to lift the ratchet away. So I'm actually holding this in the correct position right now to fit in here, like so. Ooh, and it's working. See if we can hear that. Or maybe, I don't think you'll be able to see it. Maybe. And since there's no ratchet on the rear one, it doesn't make any difference which way we put the rear one in, unless you like things cosmetically to look the same. And again, with all these wheels, you want to check to make sure that they spin freely on these metal shafts. You can hear the ratchet. Okay. This is the leg linkage piece. It prints flat like that, no supports required. This is the leg itself. This is one of the very few parts and we do put supports on, and that's only because of these cutouts here and here. It prints flat as we're seeing it, and if you didn't put some support material just right in here, you would end up with all kind of buggered edges and things would bind up. Basically, I use the Prusa slicer, and it has what they call, you can put enforcement blocks. I'll bring in a little block right here and a little block right there. When I select supports, I select supports only for enforcement blockers, and then it'll only put the supports there. It'll leave everything else about this designed to print without support. That's the only place we need to add it. So these two mounting holes are the front of the leg. These slots are the back of the leg. This piece you have to fish in first, so it's going to look like that. And might as well just lock that back one in first. Here's the back of the foot. We're going to lock this piece in, just like that. Then we're going to lock the front one in. Just like that. So there's our assembly. The only thing we haven't done right now is to glue the beauty covers on, which basically hold all those metal pins in place. These print flat, no supports required. And again, you can put your glue of choice on there, either some E6000 or some of this good stuff. You can find on my channel where I did a complete video just on the glues, in case you're a little confused on it. And I'm going to use the edge of this table to make sure that I've got that lined up right. I'm keeping the wheels off of the table. I got just the edge of the foot there. That way I can just pinch this and hold it, and I know it's going to be square. See, so basically you want it nice and flush on the bottom, and you want your edges to line up. And then we'll do the other side. Reason I hold off on putting the side pieces on until I'm done, because if you need to knock one of those pins out to free up something that isn't moving easily, it's so much simpler if the side parts aren't holding the pins in place. Okay, so there we have our new leg assembly. Now we have both leg assemblies. What are we going to do next? Let's, what should we do? Well, I think it's almost time, unfortunately, because we know this battery thing isn't dry yet. This E6000 isn't fast, it's just good. I'm tucking the two battery box wires up through the front like we did all the other wires. Just like so. In the end, and we won't, I mean I could do it now I guess, but I think I'll hold off. Here's a crotch piece. Nip prints flat, no supports, and basically in the end it's going to be glued right on like that in between the two legs, and basically it matches the original artwork for the Zom-Bot-2 that way, but it also encapsulates all those wires in the bottom of the motor and all that kind of good stuff from harm. Okay, we need to cut 2 more metal shafts with your 3mm or 1/8 inch welding rod, like so. And in the land of metric, we're going to cut them 48mm long. And for all of the right thinking people, we're going to cut them 1 7/8 of an inch long. What's going to happen is these are the 2 axles for holding the legs in place. Oh, good God. You're not going to believe what I just did. I guess we're going to do this video in 2 parts. Because what I'm going to have to do now is this leg that I just made, I'm going to have to peel one of these sides off so I can pop the pins out. Because what I've just made is 2 left-hand legs. I needed to make a left and a right, and you see because there's a curve to it and a flat to it, there is a left and a right. Forgot to look at this one when I built the one on camera. So now I actually have 2 left-hand legs. I need to turn one of them into a right-hand, and since the glue here probably hasn't set up all the way, let's find out. Let's just see what happens on camera. What the heck, right? Get yourself some sort of flat blade. I'm going to look for the whatever side looks like it might have the biggest seam. I know that stuff's going to be pretty well set up, but it isn't going to be as set up as the one that I made yesterday. Try not to cut my fingers off live on camera. Alright, it's coming. Got the one side piece off. Now I could try to get the other side piece off too, but normally I found if I get in here and just dig on the metal shaft a little bit, I can get it to come out. I only need to pull the top 2. This rear one's going to be the hard one because see, there's very little room to get any sort of blade in there. But there is just enough, and there it is coming out. So, haven't got enough of a finger to grab it, so let's get some needle nose on that. Here we go. Alright. So, since I already had a left, but I need a right, it all comes down to the placement of this leg. I need to just simply flip it over because I have one with a flat, so I want the 2 flats facing each other. So I put this back in again. Let's put the pin back in. Yeah, it never pays to try to do too many things at once. Shooting a video, explaining something, not paying attention to what you'd already done. Alright, yes, I will now have a left and a right, but I now have a rough surface where I've tried to cut the melted plastic and glue off. So I think before I try to glue it again, I'd best try and file that smooth and get as much of that off. It's still a little bit gooey. It was still melting it, so we lucked out that I noticed it so soon. I'd say probably if I'd waited another minute, I probably would have had to reprint the parts. Okay, that looks pretty smooth, feels smooth. So you can see here, it's actually melted where I pulled it up. Good glue. It's fast, does the job, very inexpensive. That's one of the nice things about, even though I just told you not to use CA glue, but if you do glue something with CA glue, you can almost always pop them apart for the very reason I was telling you not to use it, because it's fragile, because it's so hard. You can get your blade on there and tap it with something, and generally it'll just fracture and pop right apart at the glue seam, because it hasn't actually formed any sort of bond between the two. It's just a surface thing. You can normally fracture it and get it apart. So if you need to be able to break things apart or want them to fall apart on their own, use CA glue. And this is just about as fast for setting things up, because by the time you'd CA it and then spray it with your speed set fixer, this is about that fast. Only difference is this is actually permanent once it's completely chemically dried. Alright, that wasn't so bad. We now have a left and a right foot. Now where were we? I believe we were talking about putting them onto this main base part that we've started. This is the front, so let's grab a left leg, bring it up through the hole on the bottom. We're going to take one of these axles and like so. Sorry I'm not on screen. I have to use my whole body to do this. My chest. Maybe. Okay. So now I have this pin. As you can see, it's going through. We've gone through the linkage on both sides. And the pin has to not stick out because we have a body piece that's going to slip down over that to basically hold the pins in place. So now we have the rear linkage parts on. Now we'll run a pin for the front of the legs. Like so. Mind your wires so you don't pinch anything. I think I'm just about lined up. Having a little trouble lining up the right leg. I didn't check the holes on the print first to make sure there weren't any little buggers in them. Always a good idea to do that, you know. Can make things go together a whole lot easier. There we go. Alright, look at that. Now, in order to put the cams on, I'm going to have to take that rubber band off. We'll find out if that E6000 is set up at all, depending on whether the battery box falls out of the way. Hopefully it'll stay there. So now we have to get the two cams, and they're both different. Because one cam has a built-in gear, and one cam doesn't. This would be the small cam. Prints flat like this, no supports. You can see you got your D size opening that's going to fit over the motor shaft. And I'm going to put this small one on the right side of the robot. So basically I slid over the motor shaft, made sure it was around that. We're going to do the same thing on this side with this cam, but you can see this cam not only has the D opening for the motor, but has this large gear. This gear is what's going to be driving the spinning of the leg things. Now you want to make sure you put your cams, 180 degrees out of phase from each other. So since that one's aiming down, we'll want this cam aiming up. And line up your linkage and push it in. Just like that. Now, because the ends of these motors do normally have holes in them, the plastic shaft on the motors, I've kind of taken to, if I can find them, taking some small screws, and I can't even really tell you what the size are. I actually got these with some servos for mounting small 9G servos, but if you can find a small screw, you can go into there and see that there's a little hole down in there, and this will just retain, well, these particular ones may not be long enough. No, I think I would have to find a little bit longer screw, but I'm going to hunt for some screws off camera before this thing is assembled finally to hold those two cams in all the way. Now I think what might be interesting right now would be to actually run the motor, because remember this is the 48:1. I kind of want to find out if it'll even work. So I'm just going to take one of the motor wires, take this red one. I know these two yellow wires went to the switch. I'm just going to twist one of the motor wires to one of the switch wires. I'm going to take the other switch wire and twist it with the positive battery box wire. I had grabbed the red wire from the motor. I color coded the motor wires. We want the motor running a particular direction. Then I'll take the last black wire from the motor and the negative wire from the battery box and twist those together. So basically what this little test jig is going to allow us to do is drop some batteries in here and one, find out with this faster motor, can it walk or is it too much for the motor? And two, if things are turning the right direction. Alright, let's see what happens. Oh yeah, no, he shuffles right along. So it'll be interesting to find out if the motor has enough oomph to drive this upper part. This upper part should really be whipping around pretty fast. Now in the end, obviously all these wires are going to have to be neatened up and shortened, but because I'm going to put a sound system in here, I'm only running on 3 volts, I'm going to need to use a step-up voltage regulator. Now this is one of the larger ones. I've added wires to it, but see how big that is? Normally, I mean, if you want to pay the money, it's like $5 or $6, you can get them anywhere, but I buy a lot of my stuff from Pololu, and they'll have one that's about, say, just that big, the entire thing, and it'll take any voltage that's even just under 1 volt, boost it up to 5. We want a clean 5 volt power, and an actual will take voltages over that. I mean, if you over voltaged it, say put 6 volts into it, it'll then drop it down to 5. So in other words, it's not just a booster, but it's a voltage regulator. This particular one, I was just looking around on eBay for inexpensive voltage boost type things, and Got like a whole sack of these. At one point I've used a whole bunch of them. I think there were 10 of them in here initially. But as you can see, this was a USB one, where on these two tabs you could bring in your 1.5 volts, 3 volts, whatever you had, and it would give you 5 volts out. So because they were so dirt cheap, I figured, well, let's just go ahead and try them. Let's see if they're any good. And I just cut off this USB connector and put a couple of wires on there. And they seem to work pretty good. I mean, for the money, which would be dirt cheap. But they also are much larger. In the end, this piece, we're going to slide all the way down into that opening down there. So in the end, all this will be neatened up. I'll bring the two wires that come from the motor will actually connect with the two input wires, the plus and minus. Then the two 5-volt wires, which I have coming off here, I'll just run up here, and later we'll attach them to the sound system. You're going, well, what kind of sound system are you using? Well, this is a huge one, but this is actually what I will cut down and put in here. This is a greeting card. You buy them off eBay and just about any place you want. It has a microphone and a speaker, and it's got the 3 button cell batteries, and it has a record switch and a playback switch. We're going to be stripping this thing down. I won't be doing all this on camera. I'm going to describe it to you. In this case, for the text that I wanted for this, I wanted something that didn't sound like me. So I simply got on the internet and typed in text to audio or text to voice. And you'll find all kinds of free websites where you can go up there, type in whatever you want, and if you hit the play button online, then it says whatever you typed. So I decided what I wanted my robot to say, basically to warn living people to stay clear, and I wanted zombies to come over so I could chop their heads off. I just used, in the case of this laptop, the speakers basically play up through the keyboard. So I just lay this thing on top of the keyboard because the microphone's already aiming down. Would hit the record button. As soon as you hear a beep come out, then I would hit the button on the website I was at. It said its things, it records them onto the chip. Once everything is recorded, well, let's see if they're on there.
Warning. The living must stay clear. Zombies.
So, they are on there.
I'm over here.
I can't really stop it once I've started it.
Warning.
But
Living must stay clear.
once you know everything's recorded on there the way you want and you don't want to lose it, come back, snip off the record switch,
The living must stay
snip
clear.
off the play switch,
Zombies.
snip off the microphone wires, remove the microphone.
Warning. The
You
living
can go
must
ahead and
stay
take
clear.
snips and remove the button cell batteries, get them out of the way. And basically what you're going to find is the only part of the circuit, once the microphone, the batteries, the switches are gone, that you need to maintain is just this very small populated area right around this chip. So everything along here you can cut off. I bend this cap back to make everything smaller, and this is going to be where we're going to solder our positive and negative later. So you want to leave the cap, but I just fold it over the other way like this. There. Now I can solder my positive and negative on, which means I can cut off the board here. We need these components left, but the button cell batteries we've already removed, so we can cut the board off along there and along there. You end up with a much smaller board, and the speaker, you remove all the stuff from the sticky cloth, obviously. The speaker fits in from the back right into this opening in the hole there. Actually, you can see the grooved area for it. So I'll put the speaker in first, glue it in place. Then I can bring those 2 power supply wires we talked about up, solder them onto that cap, and just glue what's left of this little bit of a circuit board that we cut down to the back of the speaker. And it'll all fit down in there out of the way. I'm planning on doing all that live on camera. You can get smaller recording things. It's just that these are so plentiful and so inexpensive that it's worth the extra time of just cutting one down. And if you buy more than one, they're like $1 something or $2 something. If you destroy one, so what? You might have learned something. Plus, inside this FET microphone, there's a very valuable JFET that I've used in all my guitar pedals and sound effects. It's a very interesting FET. you take it out because it's super quiet, 110 dB signal to noise ratio, very high gain, and you don't have to bias the input. It's all built into it. All right, so what's next? So let's assume we had all the sound system crap in there. Next, we're going to be trying to build it up to the rotating body part, I think. I'm not going to... What can I do here? This whole body piece, this part here is the top, but when you print the part, prints upside down like that. Again, no supports required. Prints like that. This whole piece is going to slip down around the battery in the back. And if those wires weren't sitting there, like that, it would go all the way down. And I guess, I'm trying to think of some way we can demo this thing without, because I'm not ready to cut all these wires and solder them all and all that kind of stuff. Maybe if we temporarily pull them all up here to the top, we can continue describing this build. I don't know. Let's try it. Being that I just temporarily twisted things together, they're not real happy about me pushing them around. Just bear with me here. I'm going to try something, because if this works, it'll be a lot easier to show you the next steps. If we can get these wires up and out of the way. Say normally I would have done all the wiring before I would go to this next step. The sound system would be in, the wires would be all tucked out of the way. So I think now maybe we can put the body on. And gotta keep this stuff out of the way. There we go. Okay, so now you can see the body slid all the way down. Comes down, it's not going to go down too far. And in the end I actually glue the body on. In this case I put in like a drop of the E6000 here in the front. That way if I ever actually had to get the body off, the E6000 being a rubbery surface glue, I can actually force them apart or work an X-Acto blade up in there to get them apart. Let's check our wiring, see if things are still connected. Okay, they are still connected. They're not real happy because they're getting sucked into those gears, so I need to figure out a place to put them where they won't get sucked into the gear. They're already sucked into the gear. It's only going to get worse. If I put them over to this other side where the gear isn't, they'd be less likely to get sucked into the gear. So let's drag them over to the robot's right hand side, since the gear is on the robot's left hand side. Okay. There's less things for them to get sucked into there. Alright, so now on the top we have this support piece and a hole, and what we're going to be putting on there are two parts. Two parts that print as 4. Well, maybe 5. We're going to put a gear on there. Okay. First we have this piece here. This strange piece prints like that, flat. Again, no supports. And basically, this axle here is going to hold a transfer gear. Again, if your machine has elephant's foot, then be sure to run the X-Acto blade around. You need this gear to be able to spin free on that shaft. This whole mechanism here basically is going to get glued into the top of the body, just like that. And when it lines up, the hole down the center and everything should line up as well. This little spacer is to help hold this little gear from rubbing on the body and to keep it in line. So it's going to look like that. That gear should now be engaged with the lower gear, and let's run it and find out. Okay, it is. See it spinning? So now you can see how this power is going to be getting transferred up. I think we better tack that down onto the body before we go any further. I'm hoping I don't regret this since I haven't done the electrical part and the wiring yet. I'm hoping this isn't a mistake. I'm hoping this is okay. I think it's okay. Now, into the top of this hole here, we need to run a neck axle and shoulder axle. I print this axle piece in two parts. And you can see it actually has a trough down the center. That way we can pass wires up into the head to light the eyes. Both these parts print flat with no supports. And basically you're going to glue them together, and then this short part is going to go into this hole, and it's going to glue down there. And that's going to form an axle for the arms to spin around, but an axle to hold the head in place and yet provide power to go up. And this piece, well, let me glue these two halves together here first. We can wipe them down afterwards, so it doesn't really matter if you get a little bit sloppy. Like so. Now, this bottom part is going to get glued into that piece we just put on there. Just like all the way down. Just like that. Now, we have to make sure, and to tell you the truth, when I built the other one, and probably when I built this one, before I glued this piece onto here, I made sure, it's just the part the arms are going to connect to. I don't know if we want to call this the shoulder. You can see it's got the crown gear built into it. The arms are going to screw on out here. This is a support bearing piece. This whole piece just drops down onto this. And you kind of had to make sure that it can turn freely on that shaft. If that binds up at all, and this one is binding up a little, then you're going to need to sand on it. You know, just take some sandpaper and go around it, or file on it, or whatever. Make sure you've removed any elephant's foot from here, or go around that with an X-Acto blade. You need this piece to spin freely on the shaft that we've just made, if you want the arm mechanisms to work. What I'm trying to do now is, because we haven't finalized the wiring, is to keep that stuff tucked down out of the way, because we wanted to find out whether that motor has enough oomph to spin this upper part. It fits a little tight, so I do need to do a little sanding on that. In the end, once we glue the head on, that'll keep this from lifting up and disengaging. Right now there isn't anything to really stop that from happening. And because there's nothing to stop that from happening, it feels like it's kind of binding up. So we may not get the answer to my question right now, because that's all free. I think I need to do some sanding on that to make sure that this piece, which you can see, it should just drop down, should fit free. And it's kind of binding. And it maybe would turn a little, but you may not get the answer. Yeah, I am going to have to do some sanding on that to free that up. We're not going to get the answer in this video. I'll have to do a follow-up video, if I get it to work, of that part operating. Because if it doesn't work, I'm going to have to swap out that 48-to-1 motor back to a 120-to-1, which is what I used in this guy.
Warning. The living must stay clear. Zombies. I'm over here. I'm over here.
So it'd be cool to see them really spinning fast. It'd be cool if it works. But if the little motor simply doesn't have enough oomph, well, then that's just the way it goes. But we won't know until we've had a chance to work with that. So what would be left? Well, what would be left would be the arm parts. Both arm parts print flat. And obviously I've already painted these to have the blades look like blades. And basically these fit into this part here. I run in some long number 2 screws. Now if this thing actually spins fast enough and works, I'll probably sand down the width of this a little bit so that these fit in really loose, and maybe drill the hole out in here so that the screws I put in bite into the 2 shoulder parts but don't bite into the arm. So in other words, the arm can just hang free. Because if it spins fast enough, it'd be kind of cool to see if they lift up on their own. Right now, I purposely designed it so they fit snug so you could position them, because I knew they weren't going to be spinning around all that fast. When it comes to the head, the main head piece prints as one piece, prints flat, no supports. If you decide you're going to run wires up through that center hole, that you are going to put LEDs on the brain up inside, then you're going to need to drill a small hole at an angle to meet up so that the wires have a place to come up. Or in my case, I didn't feel like walking out and getting a drill, but I just took my soldering pencil and melted a small hole and ran the wires up. But anyway, as you can see, this is going to glue onto the top of that. And it can't go down too far. And it's set so that the spinning shoulder arm part won't bind, but can't lift up to where the gears wouldn't disengage. So you would glue the head on like that. And in this case, I used a Christmas ornament. You can find these online. You can find them in your hobby stores. This particular one, I'm trying to remember what the diameter was. This would be a 40 millimeter diameter. And 1/2 of the globe is going to have a lip, which this one does. And that's the half that you're going to want. Normally they have a little hanging hook right there. Cut that off. As you can see, then that will fit right into the top of the head, like so. Now the brain's actually the biggest file in this whole thing, is because I didn't design the brain. The brain was off Thingiverse and it was a big file to begin with. But anyway, I modified it. The 2 halves of the brain print like this, no supports. And when you glue them together, you'll end up with a slot that will fit onto that little plastic shaft and hold the brain where you want it. Then I just took my 2 red LEDs, wired them in parallel, put on a 220 ohm resistor for current limiting, ran the wires down and tacked into the top of the sound card the 5 volts, and that's how I got the 2 glowing eyes. So I think, if everything was working and looked right, then if you hadn't already glued on your crotch, then you would glue on your crotch and you'd be done. So that's the gist of the parts, how they go together. You don't have to go as complicated as I did. You could just go with the motor. If you don't have a switch, you don't even need to bother with that. Just have it so when you put the batteries in, it turns on. You can streamline it any way you want. I just took mine to this extreme because that's the way I am. All right, happy building.